Awesome. Thank you very much for coming, folks. I know we're competing with the How Are Tickets Paid For talk, so I appreciate you skipping that one to see this one. My name is Philip. We're going to talk a bit about DNS in IR, and how you collect it, how you analyze it, and lastly, how you can use it to potentially respond to events. First, the obligatory who am I slide. I believe this is required per speaker contracts. So I lead the security team at Coinbase. Have any customers in the crowd? Coinbase customers? Oh, not bad. So for those of you that aren't familiar, Coinbase is a digital currency company. We store about $500 million worth of Bitcoin, Ether, and Litecoin, which is a really fun challenge. I've done a bunch of other security stuff. I recently came to terms that I probably had to be on Twitter as a security person. I think it's required. I'm going to hold back 10 to 15 minutes at the end of the talk for questions, comments, anything like that. So if you could hold it till the end, that'd be awesome. And with that, we'll jump into this. So why are you here, I guess, is the first question we should ask. I think, and maybe a little bit more meta, like why am I up here with spending an hour of my life talking to folks. The core of it, and a piece of advice I got while I was building this talk a lot is if you want to do a talk, have something to say, then say it. So the thing I want to say is DNS logging is super important. The data is absolutely critical to a great incident response. It's easier and cheaper than you think it is, and it can be pretty actually entertaining. A couple of important notes, like first of all, I'm talking about recursive DNS here, not authoritative DNS, right? This is the resolvers you have in your environment. Authoritative DNS monitoring is a totally different topic that you should also do. For kicks sometime, just check out NX domain responses from your authoritative name servers. It's pretty cool to see the root forces. So anytime you're thinking of adding a new data source to your investigative sort of platform, I think you should ask one core question, right? What does this let me do that I couldn't do before? And I think that boils down to like maybe 3 sub-questions, right? What does this add to my investigation? How can I pivot? How does this enrich? And what can I detect with this data that I couldn't detect before I added this? Otherwise, you end up with data sprawl and no one is happy in that environment. And I think DNS has some actually pretty compelling answers sort of across the board. For those of you who don't have great proxy logs, actually a really interesting window into your web traffic without having to intercept your actual web traffic. For those of you with proxy logs with a large percentage of non-HTTP traffic that's transiting your border, DNS and NetFlow are really, and of course obviously endpoint logs, but are really your only 2 network-based windows into what that traffic actually is. It is the essentially only method for discovering DNS tunneling on the network, and nothing else is really actually going to work there. And with some supporting data, mostly some whois data, but potentially some blacklist integrations, it actually puts you into a really interesting place for alerting on this data in a very productive way. At the end, I'm going to go through a bunch of investigative, like how you can analyze this data, some leads you should pursue. But one really interesting one that I've pursued with great effect is take a look at all the domains younger than 30 days that you're resolving. By and large, legitimate sites have probably existed for more than 30 days in terms of like the registration date. Anything younger than 30 days, I tend to gray list, right? Take a look with a skeptical eye. DNS has some downsides to every data source does, right? They're always negatives. One of the negatives about DNS is that it is very chatty. So while I was doing the research for this, I decided, hey, let me just pick a random news site, reload a page, see what happens. I generated almost 100 DNS queries from reloading a single website. The trackers, the affiliated sites, it was insane. I expected maybe 30, 20 tops. So you combine that across all your users, you generate a lot of data very, very quickly. 2, DNS has sort of 2 different, in my experience, investigative paths. Right? One is the quick question answer. What does this host resolve to? What hosts have resolved to this IP? Who's queried this? What are the clients? Like the quick question answer stuff where like Elasticsearch is great at. And the other is a much more sort of batch bulk processing. Like what are the average entropy measurements over my domain names, things like that, that really ask for 2 different backends, right? It can be a complicated processing infrastructure. But we're going to talk a little bit about that. Before we get into that, I want to do a quick science experiment, social science experiment, that is. So I saw the stat from Cisco, it's on there, only 68% of companies don't monitor DNS. That sort of blows my mind. So all of you guys who do blue team stuff, just raise your hands. Awesome. Now, of those, keep them up, come on. So those of you who don't monitor DNS, put your hands down. So this disproves, no, actually we're probably pretty close to Cisco's numbers. I think about half of you put your hands down. This room holds about 300 people. There are probably, I don't know, 160 people in here. So yeah, about half of you don't monitor DNS, which is pretty close, surprisingly close actually. Cool. Down. Yes. So I'm going to assume you're all convinced and want nothing more than to learn how to monitor DNS in your environment. Otherwise, we can all go get beers. Like that's an option. Fair. So first, a quick note about names. We tend to conflate these two terms, and if you talk to a DNS guy, he will quickly correct you, as I was corrected when I first started getting into this. Passive DNS is not what you think it is. Almost certainly. Passive DNS refers to monitoring between resolvers and authoritative servers. It is specifically, it misses cache data, it misses client IPs. Its point is to rebuild the structure of the global DNS database and allow for querying. This is what like Farsight's DNS database, that kind of stuff, that's what that's trying to do. What we're going to talk about is I would call DNS monitoring, right? It is the practice of logging every single DNS thing that happens in a given environment. This is what I need when I'm doing incident response. This is I want everything, whether it's cached, failed, succeeded, no matter where it went and how it turned out, I want to know about it. And I want to know about it time-stamped and with the client IP in question pointed out. So let's talk about collection. You have three critical top-level choices to make. I should actually preface here. I'm assuming we all know what DNS is. I'm assuming we all have a basic understanding of how a DNS query flows, right? Resolvers, forwarders, authoritative versus recursive resolvers, that kind of thing. I'm just going to assume all of that. And sorry if you don't. So you have three critical choices to make. One, how do you collect the data? Like by what method? By what tools? Where do you collect it? And lastly, how do you store it? How do you query it? So we're going to go walk through a little bit about that. So collection, you have sort of four basic options, right? You can collect at your border. The pros is you see everything that happens in your network, right? Whether it goes through your recursive resolver or not, you see it all. The downside is you're not going to see true client IPs if you have internal resolvers, which can really hamper an investigation if you can't actually walk your way back to that client quickly. You're not going to collect internal requests, so if you have internally hosted domains, you're not going to see those. And lastly, you're not going to see cached requests or requests that your internal resolver serves out of cache, which can actually be a huge problem, especially if you have multiple clients querying the same malicious domain. We can collect with the resolver. So this is actually pretty cool. You see true clients, you see actual client IPs, so you can quickly walk that back in an incident response. You see internal requests internally, assuming those are going through your internal resolvers. You see all that stuff. The problem is you're going to miss anything that skips your internal resolvers, right? This happens both benignly. A lot of IoT devices, for instance, hard-code DNS servers, and it also happens maliciously. A lot of malware hard-codes DNS servers, either to point the user to a bad DNS resolver, or because they're trying to skip your monitoring. Third, you can try to collect your endpoints. This turns out to be really, really tough for all the same reasons that doing anything else on endpoints is tough. There are coverage problems, there are deployment problems, there are perf impact problems, there are data transport problems. The positive, of course, is if assuming you can get the coverage, you see everything, and you get data all the time, not just when these systems are on your network. So what you should actually do everything is the right answer here, as it makes sense for your environment. You're gonna hear me say that a lot. DNS is one of those things where we all implement it differently, depending on the size, distributed nature, the number of users, things like that. So you should, and this is what I recommend and what I do. I recommend you either block DNS outbound at your border, or you monitor DNS outbound at your border for things that are skipping your internal resolvers and get that fixed. You monitor primarily at your internal resolver. This skips the headache of trying to deploy an agent to all your endpoints. There's of course a corner case here. If you already have an endpoint, like a Carbon Black or something like that, that collects DNS requests, by all means be lazy, use it. Like, I'm a huge advocate of laziness in deployment. And then where it makes sense, you can deploy on your endpoints. So in my particular environment, I have very, very good production server deployment. So I deploy, it's also in AWS, right? Where I don't have a traditional network border, I don't have resolvers that are under my control. So I deploy to all my endpoints in prod, I deploy to my internal resolver, my border on corporate, and I get essentially 100% coverage with the reasonable effort. Now, so that's where we deploy. How do we collect? There are three core options. You can attempt to use query resolver logging or resolver query logging, which is going to end poorly for you, almost guaranteed. Query resolver resolver query logging is actually in a pretty poor state. The only resolver that does question and answer logging that I'm aware of is Microsoft DNS. Anything before 2012, if you've turned that on, you're going to have a really bad time, performance-wise. It's just going to eat your endpoints alive, or eat your servers alive. And even now, after post-2012, you should at some point, just for shits and giggles, turn this on a Microsoft server and look at the log format. It's amazing, amazingly bad, to be clear. But it is like you would have to design a poor log format. The only thing that I know is worse is Linux Audit D. That is the only thing I have seen that I would call worse than this. A couple other things to mention. There is a DNS logging protocol that's based on protobuffers called DNS tap. It only exists right now in not DNS and Unbound, but they say they want to spread it farther around. It offers obviously protobufs, right? So it's a very efficient on the wire, very, very, very quick transmission. So hopefully this moves into resolvers globally. I really, really hope it does. But so notably, right, nothing else logs the answer, which is sort of an important part of what we're trying to get at here. Which is why I basically say for resolvers, you got luck. Exceptions, there's commercial products that do this. Infoblox does a good job of logging DNS stuff. I've heard Power DNS can do this, but I have not used those, so I can't specifically say they're good or bad. Your second option, IDSs. Suricata and Bro both do protocol or DNS protocol interpretation and do log queries and responses, which is great if you already have that deployed, right? So I would use this if you have something like that deployed or can simply. I would use this on your border. I only know of one organization I've talked to that has enough IDS placement flexibility and like software taps to actually tap in front of all of their recursive resolvers internally. They're just crazy. For the rest of us, this is a great border option. You probably are already collecting this data. You can probably hook it into existing transport mechanisms. It's all reasonably easily parsable. So like, again, laziness plus one. If you're going to add this and you don't already have it, I would actually encourage you, in my personal preference, to use Bro. I like Bro because it does not just DNS, but it does a lot of protocols very, very, very well. And it's a very effective intrusion detection mechanism. So the last option we should talk about is standalone DNS logging, and this is where I pitch a thing that I built. But there are really two options here. So there's a thing called passive DNS, which is written by a dude whose name I would butcher if I tried to pronounce it. He's Eastern European of some sort. I'm not going to try it. What's that? Okay, I'm not going to try it. So it's really good. This is actually what got me into DNS monitoring to begin with. This is sort of my gateway drug into monitoring DNS in an environment is passive DNS. The downsides and the reason I built Go Passive DNS is it was written in C. It does all of its own packet processing, native to C. It had, at the time I was using it, this is developed somewhat since then. It had sort of limited output options, so it was like logging to a database or a flat file. It was logging in pipe delimited text, which is not the end of the world, but neither is it like JSON, for instance. And it was in C, so you had the standard dependency management issues when you're deploying it. I wrote Go Passive DNS sort of for a couple core reasons. Number one, I really dislike parsing network traffic in non-environments. So when, like Go, for instance, right, memory managed, which means a whole class of memory corruption vulnerabilities just goes away. I don't need to worry about buffer overflows. I don't need to worry about like parsing string safety for the most part. I can concentrate on my code. The second is that it has a Python-esque, I promise you this won't turn into a Go presentation. It's just a small tangent. It has a Python-esque library ecosystem that's really, really awesome, and again, lets me focus on the core competency of the code. It also has, I also built in like native transport mechanisms like, first of all, in JSON, because life's too short to parse non-JSON. And I built in native key-based transport, right? So if I'm running a bunch of these things all over the place, I don't want to have to deal with syslog, concentrators, and whatnot. I want to just toss it in a queue and let it work itself out. So for my money, if you're going to deploy this from scratch, if you don't have an existing environment, if you're not already logging DNS, I personally prefer the standalone DNS logging. Right? I think it gives you flexibility. I think it's sort of purpose-built. You can deploy this on a recursive resolver. Both of these options are very, very low in resource overhead in general. You can deploy this on an existing tap. If you have an IDS box that you're already running, you can deploy it there. You can deploy this on endpoints. Go passive DNS, another sort of ancillary reason I used Go is cross-platform, right? So I can compile and run this on OS 10, any flavor of Linux you want, even Windows. Although it's missing some service initialization stuff to run well on that yet. So lastly, assuming you've decided like where you want to log, right? You know you want to log at these places with these. And by the way, I'll make these slides available after the talk for those of you who are taking pictures every slide. I'll save you some effort. So we want to log this data at these places. Awesome. We're going to send it back. Using what? We haven't really talked about that yet, right? So how do we actually support this collection? Some of you are already going to have environments set up for this, right? It's as easy as plugging into your existing log transport mechanism, whether it be Flume or Kafka or what have you. And again, awesome. You should do that. Laziness again is a virtue in these cases. The generic infrastructure I like to talk about here, because there are a couple of specific requirements for DNS data to really log it very, very well. Specifically, DNS data is one of those data sources that benefits just significantly from enrichment. A couple of basic enrichments like whois data and maybe DNS RBLs or other blacklist data onto these log records make it immensely more useful when you get to the analysis phase. So I like this basic architecture, right? 2 queues with an enrichment phase in between, writing out to both an Elasticsearch and a Spark EMR cluster on the other end. This is basically what I do in prod for my DNS data. This lets us do 2 things. Remember, we talked at the very beginning, DNS can sort of bifurcate into analytical flows, the question answer style, like easy search-based stuff, and the much more complicated bulk processing stuff. This lets me do both. I can dispatch Spark drops when I want them, or my analysts can get real-time instant results from Elasticsearch queries. Cool, so you have all the data. Congratulations. Now what do you do with it? So we just talked about enrichments. Like I said, if you do nothing else, add whois data to this stuff. It is enormously useful both for domain age type questions. How old is this domain? How recently has it changed? What registrars is it registered with? Is it a registrar in Ukraine or someone that has more of a positive reputation? It's amazing. If you're going to add more stuff, add blacklist data. Very, very useful. Add GUIP on the returned IPs. That can also be extremely, extremely useful. And lastly, so back in this slide here, right? I have the Spark EMR HDFS cluster that's really, really cool. If you're not going to do that, or if you don't have that, or you can't do that, what I encourage you to do is pre-calculate some values in your processing pipeline, right? Some standard aggregations that your analysts are going to use, or some standard terms they can use to aggregate on, right? So probably the most important, if you're not going to do anything else, is parse out the domain from the host name and have that as a separate record on those log messages. That will enable a broad range of analysis later, including things like detecting DNS tunneling mechanisms that are just really hard to do without that pre-parsing. Calculating things like English word presence, query entropy, compressibility. There's some really interesting research around that. Can again help the analysts, if they only have an Elasticsearch interface, still produce pretty complicated analyses. Let's talk about that. Let's talk about that a little bit. So you have all this data. You've enriched it in some number of ways. You have this cool analysis environment. And by the way, I was when I first started doing this talk, I had this like grand plan of I'm going to build up this Amazon environment. I'm going to stand up my elk stack. It's going to be really cool and beautiful. And I realized after I did all that, that the stuff that you guys would actually see is like a Kibana dashboard with a histogram. Not really sexy for the input. So instead of like showing that, which is sort of boring, I'm going to kind of talk through this stuff. Sorry, you don't get histograms. So fast flux, right? What is fast flux? Fast flux are domains that rapidly switch between IPs. This is to make IP-based blocking hard, among other reasons. So how do you detect this in DNS logs? It's actually blindingly obvious. If you have those host names already in there, a quick histogram, literally a histogram of unique IPs per domain name, boom. You're gonna see high values from places like Google, places like that may return 6, 7, 8 results. Then you're gonna see some that are several hundred results. They're gonna be extraordinarily suspicious, and you should investigate that stuff. As with all of these, I'm gonna talk about this at the end. They're always false positives. They're always like outliers that you need to take out of these analysis. But this is why this is why humans are good at this stuff. So DNS exfiltration tunneling, the PCAP down there is actually from iodine. As you can see, it uses a consistent domain name with differing host names to move traffic back and forth. This is one of two common tunneling exfiltration patterns. The other is you can get very clever with this unused fields in DNS packets to encode individual or maybe 2 or 3 bits per packet. That stuff, if you're looking at DNS at all, tends to be very, very obvious. Because the query volume just goes insane from these hosts, moving 1 bit at a time, 1 bit per DNS query. The host name stuff may or may not increase volume significantly. What it does do is it increases unique host names per domain significantly, right? So this is where if you pre-calculated that domain field or you have that Spark cluster, running analysis and asking how many unique host names per domain am I seeing is actually very, very interesting. Now you're going to get false positives from CDNs doing this, like CloudFront, Akamai, that kind of thing. Those are generally pretty easy to parse out of your results in the whitelist as you go through that. And what you're left with is a set of unusual domains that you should really look into very closely. Now this is going to false positive a bit. I'm going to talk about this. Actually, I'm going to talk about this. This is going to false positive on other thing, like antivirus vendors do some crazy DNS stuff that looks a lot like tunneling. In fact, it is tunneling. We'll talk about that in a little bit later. So DGAs, domain generation algorithms, these are pretty easy because they generally result in a huge spike in NX domains for a given client as he's working through his generated domains trying to find the active one. Large numbers of NX domains are actually a really interesting lead to begin with, right? Once you get this data, there are a number of basic analytical questions you can start asking, like, what's NX domaining? What's surfailing the most in my environment, and why? Right? These are the threads that we can start to pull on to kick off a much more in-depth analytical exploration. So DGAs, again, very, very simple. If you're collecting the data, spike in NX domains, you should look at that. Once you look at the traffic, you're going to see what look very much like randomly generated domains there. I forget what this was a sample of. Some banking Trojan, I want to say. Low prevalence domains. So this is a really interesting one. So this sort of is related to the concept that malware should be rare in your organization, right? You can see this concept exists in file hash based analyses as well. What are the least common hashes or pieces of software in my environment? What are the least common running processes, least common registry keys, that kind of thing. It works in DNS too to some extent. Like every other area where you apply this kind of analysis, users do weird shit, right? The drift on user endpoints for this kind of stuff is insane. The tail is super long. The first time I did this analysis on data, I was super excited. Like, yeah, I'm going to find the APTs, and I found all the users, just all of them. Doing crazy stuff, and a lot of it happens because of DNS prefetch, because of random tracking domains, because of just the internet, right? Where you can apply this, I found much more effectively, is on servers. Servers should not have, and generally in my experience, do not have the same drift as client endpoints do, at least if they're well managed. Server environments, I found a very interesting approach is to do this exact sort of prevalence analysis and ask what are the least queried domains in my environment, and go ask why, right? Go figure out who owns these things, how long have they been around. You can combine these and layer this with an age-based analysis. What are the least common new domains in my environment? Again, if you either have the Spark environment or you've pre-calculated this stuff, it's an incredibly interesting analysis to do on server environments. I don't recommend it on client environments. You're going to be chasing that tail for the rest of your life. So a few other leads that you should or threads you should pull on once you get this data. Who's doing the most text lookups, right? So we saw back this. Nope. Yeah, this guy's using A records to conduct his to do his tunneling. Text records are also very, very popular to do the same sort of tunneling. One more. There we go. So who's doing the most text lookups? Now what you're going to see is this, unfortunately. This is Sophos. This is Sophos doing DNS lookups for real-time blacklists. I have no idea what the stuff in the middle there is that looks like a DNS tunnel. It probably is a DNS tunnel for some amount of information. I was very amused when I looked up. So it's at sophosxl.net is the actual Sophos domain. Sophosx1.net is for sale if anyone wants to buy it. Should offer a pretty good. If any of you guys are red teamers, that'll be a great DNS tunnel. That'd be beautiful. I can hear the Namecheap.com apps opening right now. So text records are really interesting, both in terms of which hosts are doing it most and which domains are doing it the most. Like we are talking about index domain responses, who's failing the most, who's looking up the most broken domains. This is either that server is either broken or infected, possibly both. You never know. Pure volume based, who's doing the most DNS lookups in my entire environment and why? The reverse, who's doing the least? What domains you look up the least across the board? This is actually not. Again, I would do this for servers, not clients. Clients are weird. And the last ones can actually be pretty interesting and help surface malware that's not using DNS to avoid this sort of analysis, but what's showing up in NetFlow that's not showing up as a DNS answer. This assumes you have an environment where you can do that kind of calculation, a Spark or something of that nature, but it turns out to be an actually pretty interesting set of hosts here. So common false positives, we talked about this. AV engines are notorious for this stuff. I've seen it with Sophos, with McAfee, with a few others that use DNS tunneling mechanism. Primarily, in my opinion, because this is basically free for them in terms of load, as opposed to an HTTP-based mechanism where they have to run the servers to support it. Here we basically support them. Pretty clever, actually. Some other things that commonly trip people up when they're starting to do this. Tor, Chrome, and actually a few others, when you start them up, will look up several domain names they expect not to exist, just to test for DNS hijacking the environment in which they exist. This also looks at about 9 a.m. like something bad is going on in your network because you have thousands, hundreds, depending on the size of your organization, of index domain responses. You're like, why is this happening every day between 8 and 9 in the morning? That's because people are coming to work and opening their laptops. Prefetch is the devil in terms of DNS monitoring. It's great for performance and all the other reasons. So prefetch is when a browser goes to a website, that website has a bunch of links on it. The browser decides, I'm going to be super helpful, I'm going to prefetch the results of these DNS queries before the user's actually clicked on anything. This also happens when the user's typing in the URL bar in some browsers, depending on their settings. If the user types a valid domain name, it's part of another domain name, www.cn, on their way to cnn.com. That lookup, depending on that browser settings, will happen, right? And the question is, then going back and looking at your DNS records, well, why? Why did it happen? Did it happen because the user was trying to type something else? Did it happen because the user went there? Did it happen because prefetch, they just happened to visit? There was this happened a couple of times and actually literally woke me up at in the morning. a user was visiting the Wikipedia site, I think it was, for APT1, and they linked several of the domains off of that Wikipedia site. Well, the browser went ahead and prefetched that domain for them, thank God for that, and lit the alerting system up like a Christmas tree, because they were going to it's the APTs, it's the literal APTs. It was not the APTs, it was Wikipedia. Yeah, that was not awesome. And last, CDNs play havoc with this entire field of analysis. CDNs do weird shit. If you look at like CloudFront, they use random domains, or random subdomains, .cloudfront.net. Look at Akamai, they use a number of actually naming patterns, .akamai, or .ak, DNS, things like that. You'll learn to filter these out as you do this analysis more and more, and it's going to vary depending on your environment, right? We each are doing different things. Our traffic's going to look, one way or the other depending on how that turns out. But yeah, it's absolutely filterable. So cool. We've talked about right on time. We talked about how to collect it. We've talked about what to do with it once you've collected it. Some analysis paths that you can travel down. My one meme. It's the meme of my youth. Let's talk about response. Right? So how can you use DNS for response? DNS is actually amazingly awesome for response. So I'm assuming you're all going to rush back to your jobs and immediately implement passive DNS if it's not already there, or sorry, DNS monitoring if it's not already there, and you're going to find the APTs immediately. Obviously, that's how this is going to happen. So now what? Now what are you going to do about that? So DNS is, as we talked about at the very, very beginning, essential networking, right? Almost everything uses DNS to look up where it's supposed to go for a given name, which means it's a great place to block those things or redirect them, much more interestingly, to somewhere you can control and analyze that data. So the primary way to do this is something that Bind introduced in Bind 9.8 called RPZ, or Response Policy Zones. Sometimes it's referred to as the DNS firewall, which is, I think, a terrible name. Oop, wrong direction. So what is RPZ? This is basically RPZ, right? So this is RPZ is a zone that's maintained on an RPZ server that's served by that server. It can also be maintained on your resolver itself as just a separate zone. Depends on how you want to implement it. Bind is configured to look at this zone as a policy lookup, right? So as it's saying, okay, I'm going to resolve badsite.com. Let me first look at my RPZ zone that's configured over here. Oh, look, there's a record for badzone.com over there. Let's just go ahead and serve that fake record back to this user instead of the real record that I would have had to get from the internet somewhere. It can be actually much more than that. It can give an NX domain. It can live out responses. It can do all sorts of fun stuff if you read the RPZ manual. But I think the two most interesting for us are straight up blocking and redirection to a walled garden or analysis node. So there are a few options with how you deploy RPZ. The most common, if you have more than one resolver, is your internal recursive resolvers slave a zone off of some DNS server that you control. This is really great when you don't own the DNS infrastructure, and the guys that do own the DNS infrastructure love it like a child. I've seen is the case occasionally. In this case, like you're not touching their servers. All you're doing is saying, just slave this zone for me and add this one line of config to your named.conf. And we're done. Even if my server literally catches fire and burns to the ground, it does not, the worst thing that happens is traffic doesn't get blocked. It doesn't impact the operational stability of DNS, which is super cool. And then you, unfortunately, let's see, nope. That's out of order. So unfortunately, that means you are then saddled with maintaining a zone file for all your blocked stuff. If there's more than one of you on a team, you're faced with the classical DNS admin's dilemma of how do you edit zone files safely among multiple people, which ends poorly frequently. We'll talk about that in a second. So you should use RPC for a couple of reasons. One is obviously blocking domains. Two is, and this is actually, I think, more interesting, the redirection capabilities in RPZ can push that interesting traffic to a transparent proxy. It can put it, like, for instance, this is a great idea if you're having problems with CNET downloaders and responding to stupid adware. You can use this to drop an interstitial in front of download.cnet.com, right? You just redirect download.cnet.com, RPZ it to a local IP. That's a reverse proxy that just drops a page in front of the user. Really? Are you sure you want to do this? Are you sure you want to download this adware-laden executable? Let them click through or not, whichever way you want. Easy. If that's a problem and this is the solution, I hopefully just saved you a bunch of time responding to adware alerts. Lastly, RPZ is crazy fast. It's as fast as DNS replication. And if you're using what's called zone notifies, so this is a DNS mechanism for a master to tell its slaves when a zone has been updated, you can get single-digit seconds company-wide blocking for a given domain name or client or name server or even wildcards off of those things, which is incredibly fast. So RPZ gotchas, like I mentioned, you're now stuck maintaining a bind zone file. That has its ups and downs. You're going to have a bad time if you do this with like a standard, like a malware domain list or something like that. I learned this through hard, bitter experience. The second time I blocked iTunes, I stopped doing that. Yeah, that was not good. I had to include bullet number 3 in there. Always update your serial number on your zone. If you're like not a DNS admin, you don't know how much pain this causes. Like, why is my change not propagating? Because you didn't update your serial number. And lastly, DNSSEC. So DNSSEC is an interesting interaction with RPZ. By and large, it actually doesn't matter today because clients aren't generally validating very often. So to the extent clients aren't validating, you can just have RPZ lie anyway, and the client's not going to care. If your clients are validating, you can still have RPZ mess with the records that go back. But all that's going to happen is you're going to break validation, and that client won't be able to visit the domain, which is actually what you wanted anyway. So it seems fine to me either way, which is pretty sweet. Perfect. Okay, went a little bit early. So lastly, this is where I was supposed to unveil the thing I wrote called GoRPZ that fixes much of that. Unfortunately, lawyers exist in this world. So I can't open source it yet. They're still reviewing whether I can or not. But it's really cool. I'll tell you all about it, even though you can't have it. So in all seriousness, it should be out in another week or two once I get back and can sit on them. So this is a RESTful service that's also DNS server on the back end. It uses Go's multi-threading to do that all in the same process. It takes a straight-up RESTful API using bearer tokens for auth, and on the back end, it masters its own file using, again, Go has a great package library, using Go's built-in DNS packages to handle all of the replication to your actual internal resolvers. This takes away all the zone file craziness. This makes updating a breeze. This means you can track your additions and deletions much more effectively over time. This means my favorite feature of all, you can have comments. You can say why a thing was blocked, not just that it was blocked or redirected or whatever you choose to do with it. And it's Go, so it's cross-platform, it's one binary, it's, Go-ish. Sorry I can't release it. I'm super sad about that. Lastly, and I think we're going to end early, sorry. What are your questions? In the back. Laced together. So, so no, not effectively. So the piece of information that's common when you look at like sorry. The question was if you're using like a non-transparent proxy and you see a request come in that you're redirecting to an internal proxy, and that proxy regenerates another DNS query to wherever that client's going, how do you tie that line together? The answer is hackery around time windows is the best answer there. Traditionally, there's a DNS transaction ID that's stable through that's stable through the transaction. transaction ID. But that's broken when you reissue a new query from a proxy server. So the answer is there's not a good way. But practically speaking, I would probably not pay much attention, or at least lower the severity of stuff that's issuing from the proxy server that I'm intentionally redirecting infected users to, because it's just going to false positive a lot on me. What else? Front then back.
So, through your stumbling of the prefetch,
Yep.
does that just do a DNS query, or does it actually start downloading?
So the question is, for the prefetch, is it just a query, or does it actually start downloading? In my experience, it's just a query. It's pre-resolving there are some that'll make the browsers do queries as well. It'll start pulling pieces of links that you think it's going to go to, but I'm not aware of any browsers that do that natively. And in the red in the back.
Yeah, so we're using Row, and we started to do some of this analysis, and so we noticed when users go to Microsoft, this just came up last week where we were trying to track down why servers call out when they shouldn't. And of course, we look at the idea of calling out, so it comes back to Akamai, which isn't calling to. And so we had to dig and locate it and say, oh no, they're actually on Microsoft.
Yep.
We're just determining that. So, what do you know, something you've been dealing with for a while, what are some of the things you can set up to try and, fix that so you can get the analysts the information, the right information faster, rather than have to do multiple queries and say, oh, well, let's go with that.
So what you, so the question, if I restate it, was an example of a complicated DNS analysis problem is our Microsoft updates, where Microsoft redirects to Akamai to do its update download, which makes a ton of sense. That's what a CDN's for. What are some sort of tips and tricks to better work through that process? So this goes back to like how do you store the data so analysts can interact with it effectively? If you're seeing this guy going to an IP address that's an Akamai IP address. If you're putting your data in like Elasticsearch or something like that, you should be able to very quickly search, okay, IP address, that was resolved by, that was actually Akamai, okay, what resolved that? Well, that was actually a CNAME from updates.microsoft.com. And you should be able to do that chain very, very quickly. That falls down a little bit if it's like a 302 style redirect. Like a 302, like if it's updates.microsoft.com is actually a small little server, it's just giving a 302 to Akamai. But at the very least, you'd be able to quickly backtrack that IP and know it's Akamai, which is, in my experience, a much lower severity style of lookup. And because, like, we all go through this, you now know that Akamai is distributing Microsoft updates. If you see this happening around the time Microsoft updates are coming out, like that should be the top of your mind. A lot of this is like SOPs for your network, right? Like much else in incident analysis. What else? I saw, yeah.
When I first started doing it, I saw like row stuff and everything else, and then I cleared those out and kept looking at it. Everything else is continuing to be false positives or stuff that was already being blocked on the proxy.
Mm-hmm.
Did you ever find anything? Because like I never would have seen this without doing this.
So we saw some stuff in red teams that was absolutely that we caught where the DNS analysis was extremely important. I think I've caught, so I draw a slightly different distinct, sorry, the question. After you've been doing this for quite a while, you work through the initial false positives, and you get down to like the stuff that's suspicious, and you work through that. There are just a lot of false positives. So first answer is, welcome to the blue team.
The really short thing is, did you find that it was worth it? You built two tools,
Mm-hmm.
is it worth it?
Yes, absolutely. So the DNS blocking was by far the most effective coordinated blocking mechanism I've ever used. I was in one red team event. We sort of detected through other means. So we discovered the red team. They were using a specific hosting provider to do their red teaming. We backtracked that and were able to call in a favor to get the list of domain names that was involved in this, and we were able to stage a coordinated block across our entire infrastructure all at once with maybe 5 seconds of latency from the first DNS server to last DNS server, and effectively decapitate the entire that entire intrusion, red team intrusion. In other environments, a lot of the false positives are actually badly misconfigured systems that like actually fixing those is I would call a win in and of itself. It's not a security win, but it's a real win. Yeah. What else? Yeah.
So you mentioned doing quiz lookups and all the machine learning.
Mm-hmm.
You know, large organizations that can be hundreds of thousands of lookups a day.
Mm-hmm.
If you have any issues with, I mean, how do you do that? Do you just do an errand query?
No. Yeah. So thanks for asking that. I forgot to mention this. I'll even those in my notes. So there are a couple of API services that do this. I've used like Whois XML API, for instance. There are a few others. Domain Tools has a parsed API, things like that, that can easily handle hundreds of thousands. The second thing that I would encourage you to do is set up a caching proxy for that locally. There's really no need to requery a domain name a ton of times in a given day. And I think you'll find as you do the analysis that you have a large number of domains that are getting very frequently queried that you probably don't need to update 1,000 times a day, and you have a much smaller number that are being queried once or twice. After the first month or so of running through this with a caching proxy for that endpoint, the number of queries that actually reaches your API provider goes way down. What else? Nothing? Outstanding. Got time for a beer left for the next talk. Thanks, guys.